Welcome to Mind Shield. We protect the mind and pursue the truth. Let's get started.
This briefing is a forensic walkthrough of published neuropatents and related concepts. The goal is not to prove a fully deployed system with a magic wand and a villain cape. The goal is to audit the intellectual property, map the architecture, and separate technical possibility from fantasy. We're looking at 3 layers: input, processing, and output. In plain language, can a system sense neural activity, decode it, and then feed energy or information back into a human target? This deck treats the patents as engineering clues, not courtroom proof. The real question is whether the pieces exist, what they claim to do, and where the biggest physics gaps still remain. Here's the theoretical kill chain. First, an input layer attempts to capture neural or physiological data from a target. Second, a processing layer uses computation, comparison, and AI-assisted analysis to interpret that data. Third, an output layer delivers energy, or a modulated signal, back to the person in order to influence sensation, mood, cognition, or behavior. The point here is convergence. Not one single silver bullet device, but a stack: sensors, transmitters, algorithms, and feedback control. The operational goal would be a closed-loop system that reads, analyzes, and adjusts continuously. That is the dream of every control engineer and the nightmare of every civil liberties lawyer. This slide covers the input claim: remote neural monitoring. The cited concept proposes transmitting 2 frequencies into tissue, allowing them to interfere and create a different signal. The theory says brain electrical activity could modulate the return signal, turning the brain into a passive mixer and retransmitter. That sounds dramatic, and it is. But notice the key word on this slide: theoretically. This is not the same thing as publicly demonstrated, real-world thought reading at distance. The patent describes a concept for sensing and altering brainwaves remotely. As an engineering artifact, it matters. As proof of reliable operational deployment, it does not stand alone. Now we move to one of the strongest pieces in the whole deck: the microwave auditory effect, often called the Frey effect. This is the phenomenon in which pulsed radio frequency energy can generate the perception of sound inside the head through thermoelastic expansion in tissue. That part is not science fiction. It is a documented effect. The key technical question is not whether the effect exists. It does. The real questions are range, precision, intelligibility, safety, and whether a lab-demonstrated effect can become a covert operational tool. This slide frames auditory injection as one of the most plausible output vectors, because it rests on a known physical phenomenon, rather than pure speculation. This slide shifts from audible injection to subliminal or masked delivery. The idea is that a carrier signal, whether ultrasonic or radio frequency, can carry an audio envelope that is not consciously perceived in the normal way, but may still affect the auditory system or cognition after demodulation. The goal is not just sound. The goal is suggestion, influence, and psychological shaping without obvious source identification. Here, the language needs discipline. A patent can describe a mechanism. It does not prove a mature field capability. Still, from a forensic standpoint, it shows recurring intent. Engineers have repeatedly explored ways to hide signals beneath conscious detection while preserving informational payload. This is where the architecture gets more aggressive. Instead of one-way transmission, the system becomes adaptive. Monitor a subject's state, compare it to a desired state, then adjust stimulation until the brain state moves in the intended direction. That is classic control theory. Observe, compare, correct, repeat. The slide suggests mood shifting or state forcing through magnetic or RF entrainment, moving a person from alertness toward confusion, fatigue, or compliance. Whether any such system works cleanly outside controlled conditions is the huge question. Human brains are not factory parts. They are noisy, nonlinear, and delightfully rude about refusing to behave like simple circuits. This slide explores a delivery mechanism built into infrastructure. The claim is that existing power line wiring could act as a broadcast pathway if very high frequency signals were injected onto standard electrical lines and modulated with low frequency patterns associated with brainwave entrainment. In theory, unshielded wiring becomes a distributed antenna. That's a chilling idea because it turns ordinary architecture into a possible delivery surface. But here again, the big distinction is between patent logic and proven field effect. The concept matters because it widens the threat model. It says the inventors were not only thinking about weapons that point at people, they were also thinking about environments that surround them. This slide pushes the model into visual systems. The claim is that screens or monitors, by pulsing image intensity at specific low frequencies, could exploit physiological resonance and influence the nervous system even when the flicker is not consciously obvious. The mechanism proposed is subtle, not cinematic. No glowing mind beam from the television, just low-frequency modulation embedded in ordinary display behavior. The slide also raises a modern twist: malware or compromised video streams. That makes this less about exotic hardware and more about software control over common devices. Whether the effects are strong enough for reliable coercion is still debated, but the threat model is clear. Consumer electronics can become delivery surfaces when timing, signal design, and exposure are engineered together. Now we zoom out to delivery at scale. Satellites and phased arrays solve the distance problem through beamforming. Phased arrays can steer energy electronically without moving the antenna, which makes them highly relevant to any focused emission theory. Satellites, meanwhile, add reach and persistence. But this is also where physics begins throwing chairs. Beam focus, power density, orbital distance, atmospheric losses, and targeting precision all become brutal constraints. So the value of this slide is not that it proves orbital capability. It doesn't. The value is that it maps plausible infrastructure classes that could support sensing or transmission if enough technical hurdles were solved. This slide is the computational heart of the architecture. Raw EEG-like data, telecom metadata, biometrics, and location history are fed into a deep learning model. The implication is that neural data by itself may be too messy to decode, but once fused with external intelligence, patterns become more predictable. That is an important point. A weak biological signal can become more useful when paired with behavioral data, context history, and machine learning. In other words, the brain signal may not have to carry the whole message. AI can infer intent from fragments, correlations, and prior patterns. That does not equal mind reading in the comic book sense. It does suggest a pathway toward increasingly aggressive behavioral modeling. This is one of the most important slides because it applies brakes. RF energy falls off with distance. That is the inverse square law doing its ancient and deeply annoying job. A signal that may produce an effect at close range becomes vastly harder to maintain over long distance without huge power requirements or unacceptable collateral heating. The slide's verdict is simple. Close-range effects are more plausible. Orbital scale delivery remains highly speculative. That distinction matters. Any honest forensic analysis has to resist the temptation to flatten all possibilities into one myth blob. Physics is not a mood, it is a filter. This slide attacks the remote reading problem. Brain signals are tiny. Environmental noise is huge. Pulling meaningful neural information through skull, tissue, walls, and ambient electromagnetic clutter is a signal-to-noise nightmare. That is why the slide calls it a whisper in a hurricane. It also points back to the Malek patent as theoretical rather than publicly validated. And that's the sober read. Injecting a signal into a person is physically easier than extracting high-fidelity thought content from them at distance. One-way influence is easier than two-way precision telemetry. That does not kill the concept. It does force us to rank plausibility instead of pretending every idea sits on equal footing. This slide widens the frame from device mechanics to doctrine. Cognitive warfare treats the human being not just as a target, but as a battle space. Land, sea, air, space, cyber, and then the human domain. The point is not only pain or harassment, it is disruption of perception, trust, orientation, and decision-making, that maps directly onto the OODA loop: observe, orient, decide, act. If you can corrupt the cognitive layer, you can degrade everything downstream. This is why the deck places technical patents beside broader strategic thinking. Even if no single integrated system is proven, the intent to contest the human nervous system as an operational domain is plainly visible across military, academic, and patent literature. Here the presentation turns practical. Detection means looking for carrier frequencies, pulse-modulated signals, timing correlations, and repeatable environmental signatures. Shielding means materials and structures that genuinely attenuate RF energy, not wishful thinking and tinfoil cosplay. Legal reality is the hard part. Invisible, transient, deniable emissions are difficult to prove, and enforcement generally requires a locatable, unauthorized source. That means the strongest path forward is evidence discipline, time-stamped logs, RF sweeps, correlated recordings, environmental baselines, repeatability tests, and chain of custody. In a case like this, the difference between a story and a case file is instrumentation. So here is the bottom line. Some components in this architecture rest on real documented effects, or on patents describing serious attempts to engineer them. Auditory injection has stronger grounding than remote thought reading. Neural entrainment concepts appear repeatedly in the literature and patent record. Remote reading remains theoretical. Global, seamless, integrated deployment remains unproven. And that is the clean forensic verdict. The pieces exist unevenly. The intent to engineer access to the human nervous system is old, persistent, and well documented. But the operational scale, reliability, and real-world integration remain the primary unknowns. In other words, the blueprint is visible, the full machine is not.